Hello everyone, my name is Shikhar Vats and me along with Wen Hao Chen have been working on the research project for this class. The topic of our project is infiltration or exfiltration attacks on the Android devices. Now let's get started. So this is the basic flow of a presentation. We're going to give a brief introduction to a problem, then talk about the project structure, and we'll then talk about the demo. In our presentation, we actually present an attack against Android devices which are connected to the IA state Wi Fi network on campus. So, the information that we're trying to exfiltrate is any private information from the victim's device, and we plan to infiltrate the victim's phone with touch inputs and file systems to cause a denial of service. Now, to do all this, we're going to use the Android debug bridge, which is one of the versatile tools provided to us by the Android. It's basically a command line tool. It lets the users to debug, but if you ask us, it lets the users to do more than just debug the applications. So talking about the project structure, our project structure can be divided into three basic components. One is a honeypot server, then the victim device, and the third is the hacking terminal. So what exactly is a honeypot server? It's just a simple computer which is going to initiate and maintain a connection with the victim using the Android debug bridge. Its basic job is to receive requests from the attacker, then it's going to pass the request to the victim's phone, collect the output from the victim's device, and then send it back to the attacker. Now all this is going to happen really fast, and we can possibly disguise our server as a fake charging station, something which we're going to talk about later in the in the next slide. The second component is the victim's device, which we are assuming it to be an Android phone. And the third is the terminal, which is basically the Android application that would be used by the adversary or the attacker. And we have our we have our hacking application installed on the device. Now, just for the assumption of this demo, we are assuming that the victim has already given the ADB debugging permissions to the honeypot server. Because the thing is, in Android, if you want to perform the USB debugging through ADB, you need to give permissions to the computer once it gets connected with the USB connection. Now, in practice, we can social engineer this uh, by one following way. So we can set up a movable mobile health checkup desk across the campus, and we offer the students a service of free checkups of their Android devices, and we tell them if their phone is facing any vulnerability or if it's infected with a malware or something. And then when the victims come to desk, we have them approve the USB debugging permissions by connecting it to the phone. And the thing is, in the background, we are actually recording their IP addresses of the devices. And one interesting thing is that once the user is connected to the honeypot server, and let's say they leave the campus, the thing is that their IP address remains the same for at least 12 hours. And even if they get disconnected in between, and then if at a future time they reconnect to the same network, the IP address doesn't change. It remains the exact same. So once the people have approved the USB debugging permissions, we have their IP addresses recorded, and then we can perform the future attacks. The thing is that in this age of technological advancement, most of the people are aware of the USB debugging permissions, but we those kind of people are not our targets. We target the users who are unaware of the working of USB debug permissions. Now, in the second video, we would show you a presentation or a demo of a presentation. Hello everyone. So for our research project, the exfiltration and infiltration of the Android devices connected to the Iowa State Wi-Fi. This is an experimental demo setup. So I just introduce you to all the components. Starting from the top, we have the server. You can think of it as the fake charging station or the honeypot that would allure the victim to connect their phones to the charging station. Going further down on the left, you can see the mobile device that would be used by the victim, which is an Android device. On the right is another Android device which would be used by the attacker or the adversary. The attacker's app installed on it. Let me go and start the app real quick. So this is the first screen of the app. Here you can see the IP address of the server. Now first I'm gonna go and initiate a connection with the server. Now, right now, what it is supposed to do is populate the list with a list of all the devices that are connected to the honeypot server. Now, since we do not have anything connected to it, we don't see anything. Let me go and initiate a connection real quick. Now, I initiate a connection. Now, what is happening, what is going on in the background is that the server, it's creating an ADBA connection with the victim's phone, and soon you can see the list that would be populated with the connected devices. Since we already have one device, we can see only one row. Now, the information that you see right now is the device ID of the victim's phone. Now, one important thing, the server has already maintained a ADB connection. Now, even if I remove the USB cable, we would still be able to perform our application's functions. I'm gonna tap on it, and here are the two possible functionalities of the app. The first one is the input gesture. The second is the receive live updates. For now, let's start with the receive live updates. Now, here again, you can see two options. One is the video, one is the log. So what the log basically does is it populates the log view with all the information that we can fathom from the device, including the codes the codes that the manufacturers use, then also with all the processes that are running in the background or in the foreground on the victim's app. For now, we are parsing the input, so we have limited string values showed on the screen. Now let me explain you what these values mean. So starting from top, we can see the device ID. Then we have the serial number of the device, then the IP address of the victim's phone. Then we can see information on whether the victim's phone has an active USB connection or an active internet connection, which you can see are false and true respectively. Then we know the product code that Google uses for that phone, which is Sailfish. Then the model, Pixel, because we're using the Google Pixel. Then we can know if the screen is on or off. Then the resolution, the orientation, and if we have a screenshot available. Now, second, in the following lines, we will see the information of all the processes, not all, but basically the list of past processes that are running on the victim's phone. So, for example, in the foreground, we have only the launcher running because we don't have anything else, right? And in the background, we are only showing three apps which we are considering for this video. First is the Android email application. Then we have the Facebook application, and it shows the video status, which is nothing because we don't have anything interesting going on. Now we have programmed the server as such that whenever there is an application in which we are interested in running on the victim's phone, it's automatically going to have a screen capture of the video that is going on. So let's say the user goes and he wants to do Facebook. He starts Facebook and now he has to log in. He will type his password. He is using Facebook as usual. And I'm gonna go and request a video clip. Sending a request. You can see we have the recorded capture of the user actually typing his login credentials, the password. Now you know the ID and the password of the user. We already have the user ID mentioned there, but you can obviously see the password. Now, right for now, we are only requesting 15-second clips, and this is the same video again. Now this is the latest video. And one interesting thing that we noticed is in some applications like the US Bank, let's say the user The user has an account in the US bank, and he opens the bank application, enters his credentials. Now let me request a video. Let me see what's going on. Let me see the credentials of the user. It takes a while for us to receive the video. See, we don't see anything. I guess that's a safety feature that the US bank uses, that we cannot capture anything that's going on in the background, but we can still we still know all the key events that were going on. Oh, that's not right. Okay. And next we'll move on to showing the different functionality, which was the touch event, touch gesture. You can see three different functions in front of you. The first one is the text view. What it is going to take is the the x and y coordinates of the touch that we want. So let me start with let's say 340 and 450. Let's see if that leads to the result. Tap go. As you can see, the touch event actually happened on the victim's phone. Now for a second, I'm going to show you what the sabotage one does. So what it's going to do is it's going to create the calling activity, start up the phone, and then call a custom number that we have programmed into the device. Right, since right now we don't have the cellular connection enabled on the victim's phone, the call didn't go through. But we don't have any function for the sabotage tool right now, but the possibilities are unlimited, as you can think. So one other interesting thing that we noticed is, so even if the user stops his Wi-Fi connection, or if he disables his Wi-Fi connection and he goes to his home and then he comes back later and connects to the Iowa State Wi-Fi again, he connects to the same IP address, and our honeypot server is actually keeping a record of the IP address, which is a pretty cool thing. I guess that's one thing with which how the Iowa State Wi-Fi implements its policies. Thanks for watching our video. Hope you like the project.